So I'm going to actually look.
Chase, you out there? Chase? Chase, you're out there.
Yep.
Okay, you can hear me and everything's good. Great. Anything concerning you? Nothing is
Well,
good.
I don't think so. I
No
just joined early because I was bored.
No is a good answer. I'm actually sitting here getting reservations for my wife's birthday.
What do you plan on doing?
There's a little French restaurant that's out by Fort DeSoto that we're going to end up going to. So,
That was nice.
yeah, it's amongst other things. She's already connived into my cooking her 2 different dinners. So just the way it goes.
Is that one of those restaurants that you have to make reservations like a week in advance?
I hope not. I hope not. I'm hoping to go there on Saturday.
Uh,
So we'll see what happens. Yeah. All the normal French things. So that's great.
yeah, me and my friends from high school, we tried to go to a restaurant in Tampa. And when we got there, it was like a 2-day reservation thing.
Really?
Yeah.
Where was it?
It was the Eulalie.
I've eaten there. Yes. I've actually eaten there probably in 4 or 5 occasions. It is excellent.
It's pretty good. I don't know why they had a 2-day waiting list. It was packed.
That's because it's that popular.
Yeah.
It's probably, you probably pick one of the more popular places in Tampa to get to. Oh, I have other people. How nice. Faith is here. Oh, you in, Faith?
Yep.
Good enough. Great. Do you have any questions?
Not for lecture, but for lab.
Okay, I'm here.
So I was looking on the calculations page and
Okay, first of all, help me out. You have to understand, I'm teaching 9 classes. All
okay,
right?
I'm Tuesday lab.
Yeah, that helps a little bit. Which experiment are we dealing with?
The binary mixture.
Oh, piece of cake. All right, what do you got?
So on the calculations page and some of the student data, I think one of the trials is like, hold on, let me see if I can pull up the information, because I was looking over it with a couple of other people from the same lab class.
Are you saying that the data's bad?
No, not that the data isn't bad, but there was something on the calculation sheet that didn't make sense to me. It was
Okay.
I'm sorry, I'm just pulling it up really quick.
Nope, go for it.
All right, so for trial 2, we're given the mass of a half-full test tube, but it's a half-full test tube. Wait, did I look at this wrong? No, never mind. I meant for trial 1.
Okay.
We're given a full test tube and a half-full test tube. On the calculations page, it says to subtract the mass of the sand salt mixture with like the whole thing versus like subtract it with half of.
Yep. You're reading it. You are reading it right, and it is as it says. Okay. Faith, what you did was you emptied out half of the contents into the beaker, right? So if you have the weight of the test tube and the full amount, You put half of the contents in the beaker, then you put the stopper back on and you weigh the contents of half of the amount and the test tube.
Uh-huh.
That gives you the amount of mixture that you put in the beaker.
So I'm
All right. This is exactly why chemists should never write anything. Absolutely. Chemists, because it is so totally convoluted. All right. We have a full test tube. Okay.
uh-huh.
Let me try and. Sorry, I'm going to draw some things.
No, that's all good. Thank you.
Okay.
Mhm.
Right. Are you seeing this or not?
I can see it.
All right. You see full test tube, right?
Yep.
We get the weight of the full test tube. Then we take this test tube and we dump out half of it.
Uh-huh.
Okay, so we have half of it left, right?
Huh?
Well, the amount from here to here, right? That
Yeah.
went into the beaker, right, Faith?
Went into the beaker.
Because we took the full test tube, emptied some of the contents into the beaker,
Okay.
and then we still had some left in the test tube, right?
Mm-hmm.
So if we weigh the full test tube, and then after we dump half of the contents in the beaker, we weigh the half-filled test tube. If we subtract those two, we've got the weight in the beaker.
Yeah. Okay. So we
So-
were solving for the mass of the salt sand mixture in the beaker,
Correct.
not in.
Go ahead, keep on talking.
So it goes into the beaker, and then we don't have to worry about whatever is left over in the test tube.
For right now.
For right
Okay,
now.
that's trial 2.
Oh, okay. That makes a lot of sense.
Don't you remember when I started talking about this, I said this is a convoluted thing? It's hard to wrap your head around it. Okay? If he'd have just given you 2 damn samples,
Yeah.
there would be no problem. But okay, what you're doing, you've got for the first trial, you've got the full test tube.
Mm-hmm.
Empty half of it into the beaker, then you weigh the test tube with half of the solid in it.
Okay.
The
Okay.
difference between the weight of the full and the weight of the half gives you the amount of the mixture that's in your first trial.
Okay.
All right. Then you put the water in it, stir it around, filter it out, and you're going to eventually get the weight of the sand, right?
Yeah.
And that will be the weight of the sand in the first trial.
Okay.
Now you do the second trial. You've got the test tube with the half-filled test tube. You've got that weight, right?
Yes.
You dump the rest of the mixture into the second beaker.
Okay.
You weigh the empty test tube. Now you have the weight of the mixture in your second trial.
Okay. All right. That makes a lot more sense now.
Good. Who else do I need to broadcast this, or are you okay with it?
I'm okay with it. I'll mention it to the people that I was working with for the lab.
Please do that. All right.
Okay. Yeah, definitely.
Please do that. I will probably, it's number 45 on my list of things to do, okay? I will try and email it to everybody tonight, okay?
All right.
And
Thank
I don't
you.
know whether I'll be as succinct as be able to explain it to them. It's much better like this, where we have a give and take, rather than trying to do it through emails.
Yeah.
How about it, everybody else? Is there anything anybody else has got for me?
Nope.
Anybody have a
Thanks.
Anybody want to make a reservation for me for a French restaurant for me and my wife on Saturday?
I don't know any French restaurants, but I could look some up.
Oh, I know of 2 of them.
Okay.
Maybe awarding
Absolutely.
extra credit.
What's that? You
Well,
guys always want
could that be
extra
awarded?
credit. You always want extra credit. No, I'm not giving you extra credit for that.
Professor, I'll pay for it if you give me an A.
Guys, I've always told you, everybody has their price. I literally have 8 more semesters. I have to make it to 8 more semesters. Then I'm going to be 66 and a half. Okay. You see, if I help you and I get caught cheating, that means they're going to fire my butt, right? So all you have to do is pay my salary for 8 semesters and I'll give you an A, Chase.
I don't know about that one.
You see, you
I mean,
should
he
have
can at
taken.
least pay for a fancy French dinner. That's worth an A to me. He didn't give you a price limit.
Ooh, that's true, wasn't it?
So Chase, how much are
Well,
you
actually,
willing
if
to
you guys
spend
were
for
all
an A?
smart, if you guys were all
Good,
smart
Professor.
and chipped in, if you chipped in a little bit each, you could get Chase his A.
Yeah, guys.
Mm.
You got to know how to market this, guys. Anybody have any questions about anything? Okay.
Yeah,
Anybody,
for once.
anybody confused about the lab, the sand lab, sand and salt lab? Hold on 1 second. I'm sorry, guys. I have, this would be good if I knew how to split people out into chat rooms. Elizabeth? Elizabeth,
Yeah,
are you okay?
yes.
All right, all right. There's a reason that I haven't replied to your brother's email, okay?
I wasn't even aware my brother sent you an email.
Okay, that is part of the reason why, I'm being as cryptic as I am. I'm not allowed to talk with him. Okay, Elizabeth?
Okay, yeah, that's fine.
I
have-
have to actually talk to my boss to see how much I can say, all right?
Okay, yeah. What?
But
How
are you okay? Are you okay?
Yeah, I'm fine. How did he contact you though?
Email.
Over his? He doesn't have an SPC account.
No.
He got onto my account last night.
Let's not say anymore, okay, Elizabeth?
Okay, thank you.
I'm sorry if I got anybody into trouble or anything, but I can't comment on it, all right, Elizabeth? Guys, it's not all that cryptic, all right? How we doing? Anybody else have anything? We doing okay? I only got I lost 17 people.
Can I go home?
Terry, you can always go home.
Aren't you home already?
You can go home absolutely if you want. You know something, Terry? It'll only cost you 50 participation points.
Oh, I think
Everything.
I'll take the points. You know, I think I'll stay.
Everything has a price, guys. Everything has a price. Okay? So what kind of food do you got? If you're not going to talk to me about chemistry, what kind of food do you like? Your favorite restaurant you've ever been to?
Ooh.
My boyfriend's currently shoving chicken nuggets at me.
That's the dream right there. You got the dream.
I know, he's awesome, right?
With or without sauce?
He has ketchup and buffalo.
Ketchup?
Yeah, what is that?
I love ketchup.
Can you repeat that? My sound glitch.
Ketchup?
Yeah,
That was a question mark.
it's homemade. So I have to.
All right, time out. If you've ever been to Houston's restaurant, Houston's it's the only ketchup I eat. They do their own homemade ketchup. It's phenomenal.
Okay, duly noted to get on Professor's good side. Let's get
Well,
on
what's the
some
chemical
ketchup.
symbol for ketchup?
This guy here.
KT, obviously.
I made my best friend a chicken nugget sauce train for her birthday this year. Like a
That's
little
illegal.
toy
That's
train.
illegal in 10 states.
Oops. Is it in Florida? Because it's too late.
Well, a lot of
Any-
things are illegal and legal in
Yeah.
Florida, so a crime like
point.
that hasn't come across my desk yet. So I think you're okay.
Cool.
I don't think the Florida man would care.
Yeah. He might
Florida
like to
man
come over
has
for
no
dinner.
boundaries. During COVID, I was like, Florida man does not give a crap about COVID. It's crazy.
Has anybody ever read Tim Dorsey? Oh, phenomenal author. He's the absolute pinnacle of Florida cynicism. Absolutely wonderful.
What's his name again, sir?
Tim Dorsey actually used to be a newspaper guy for the Tampa Bay Times.
Yeah, his name sounds really familiar.
Yeah.
Serge is his main character.
Okay, I know exactly who you're talking about now.
Serge likes to do some strange things to people.
Like Florida man?
Yeah, well, like put them in anthills with honey on them and stuff like that. Even worse than that. Where am I at? It's
Yeah.
5:30. Thank God I've reached the bell. All right, ladies and gentlemen. This is where we were. We were talking about swinging. Remember that? Remember that, Terry?
Yes.
All right.
Unfortunately.
That's never going to get wiped out of your head, is it, Terry?
No, sir.
I mean, at least he took something away from your class, I suppose.
Hey,
We all
to be
did.
honest with you, that's probably the best anybody has ever taken away from my class.
Look, I even teach my own classes and I can't top that.
All right, Terry, you're up. Okay, I've got
Alright.
these two chemicals. I recognize them as being both ionic because they both start with metals, right?
Right?
What type of reaction am I talking about?
Double replacement.
Double replacement, good. So if I'm dealing with a double replacement reaction, what happens? What are my products? Again,
AlNO3 and PbCl3.
no. Slap. Don't deal with the subscripts right now. We'll deal with the subscripts in a second. But you are right. AlNO3 plus PbCl. Okay. Now we are going to go up to our solubility chart. And we're going to actually intensify it a little bit. Terry, we have AlNO3. Al is up here. Take it all the way over to
Go
NO3.
across to NO3. We got an aqueous.
Aqueous. Got to look at the other one. Okay. Ah, crap.
Lead and what's the other one?
Chlorine.
Lead and chlorine. All right. One sec. You got it solid.
Do I have a reaction?
Yes.
Have a reaction. So we're stuck. We are stuck with doing this thing. We can't just put a whole new reaction on it. So, sorry, where I'm at. Okay, so we're at this point. Now we've put the things together. Remember, guys, do not carry over the subscripts. Okay? So we have Al. Kaylin, what's the charge on Al? As she secretly searches through everything. She's going through
I'm looking
trash
for my
bags.
periodic table. I got
She's
it.
jumping through her desk.
I
Things
just
are getting
reorganized
thrown
and I lost
everywhere.
everything. And I
Even your
cannot
marbles,
find,
especially your marbles.
yeah. Charge on Al
Yes.
that we have paired with
Cl3,
Cl3, so then it would be +3.
positive 3. Now, do you happen to know, Kaylin, what the charge on NO3 is?
I can in 2 seconds. NO3 is -1.
So look on the product side. Al is a +3, NO3 is a -1. How am I going to balance that chemical?
We need a 3.
Thank you very much. Where's it going to go? Is it going to go on the Al or is it going to go on the NO3? We have a 50-50 chance
On
here.
the
No
NO3.
pressure, no pressure at all.
I'm frazzled today. On the NO3, we need a 3.
NO3, absolutely. So what we're going to do to balance the Al and the NO3, we're going to put parentheses around the NO3. We're going to put a little subscript 3. Okay. Now, Victoria, Caitlin was nice enough to tell you that NO3 has a -1 charge.
Mm-hmm.
If I'm looking at this reaction and I know that NO3 has a -1 charge, what is the charge on my lead in lead NO3 taken 4 times?
What's the charge? Doesn't,
You just sounded like a snail dying.
that's just my life in general, Professor. I am the salt queen, so salt is always raining down on me and I'm just dying. So it has a doesn't it have a minus.
No, slap,
No.
slap, slap. It's a metal. Metals always have pluses.
Okay. We're not talking about this, the chart. It's not a +1.
No,
Lead?
there are the lead. Lead in PB. You see this compound, PbNO3 taken 4 times.
Yeah.
Each of the NO3s is a -1. What's the
Okay.
total? What's the total negative charge? How many negative ones do you have?
Negative, so it'd be -4.
So that balances with a positive.
4.
So what's the charge on the lead?
4.
So if it's a +4 on the reactant side, it's going to be a +4 on the product side.
Right.
So how many CLs do I need to put there?
4.
And magically, if I was in the slideshow, it would be magically. Magically, that's what we have. Okay. Now, Hunter, we got to balance this crazy ass thing. Are my aluminums good, left and right?
No.
Okay. How many aluminums do I have on the left and how many do I have on the right?
On the left, you have 1.
And the right?
On the right, you have 1.
So
3.
they're balanced. No,
Or yeah.
the
Okay,
3.
you're freaking me out. You're freaking me out.
Sorry, Hunter. You have
Guys,
one
put your
on each
finger up, 'cause-
side.
Okay, yeah, we have 1 on each side. Yep.
All right. How about the leads?
Okay, that's looking like that's 1, and then on the left, and then 1 on the right.
So my leads and my aluminums are balanced, right, Hunter?
Yep.
Okay. Now let's talk about the chlorines.
Okay. They're not.
Okay. I've got how many on the left?
3,
How many on the right?
4.
How do you think we're going to fix this?
We gotta. I mean, we have 4 and 3. That's 4, 5, 6, 7.
Remember, Hunter, the only way we can fix this is by putting something in front of this that can multiply by the 3 and something in front of this that can multiply by the 4.
Yeah, but wouldn't that change the aluminum? The aluminum?
Trust me on this, okay?
Okay.
Just do it. Take that step off that high board.
What?
Take the step off the high board. What are you gonna put in front of AlCl3?
Probably 2.
If I do that, that gives me 6 chlorines. Is there any way I can put something in front of the PbCl4 that's going to equal it? 4 and 3, what's the least common multiplier? What's the least common multiple of 3 and 4?
Hold on, I'm just trying to think.
Hunter, hand it off.
12.
12, yes, 12, right. So what do you have to multiply 3 by to get 12?
4.
4. So we're going to put a 4 in front of this.
Yeah, but isn't that going to change that chlorine?
Trust me. Okay? Trust me on that, okay? I'm going to put a 4 in front of the AlCl3 and a 3 in front of the PbCl4. Okay?
Yeah.
So I have the top one there. Now I have to deal with my NO3s, Hunter.
Okay.
I've got 4 and 3 again. What am I going to put in front of the leads?
4.
If I do that, I got 4 times
12.
4.
Yeah,
Hunter,
no.
if I put a 4 in front of the lead over here,
Yeah.
that's going to give me 4 times 4 nitrates. Do I want to put a 4 in front of the lead?
No.
What do I want to put in front of the lead?
A 1?
If I put 1, that gives me 1 times 4. I'm never going to get the right side equal to that.
Oh. I'm not sure.
Great answer. Let me see who else
Sorry
is
to
in here.
disappoint you there. I'm kind of just in a fog.
Okay. Cash, you out there, Cash?
Yes.
All right, Cash. You see our problem here? We have 4
Yeah.
nitrates on the left. We have 3 on the right. I need you to get them so they're even. I want
So put 3 on the left one and then 4 on the right one.
All right, I'm going to do that. Now follow with me, Hunter.
Yeah.
I got 4 times 1, 4 aluminums on the left.
Yep.
4 times 1, 4 aluminums on the right. I got 4 times 3, 12 chlorines on the
Yep.
left. 3 times 4, 12 chlorines on the right.
Yep.
3 times 1, 3 leads on the left. 3 times 1, 3 leads on the right.
Okay.
3 times 4, 12 nitrates on the left. 4 times 3, 12 nitrates on the right.
Wait. Hold on. But what about the 3 in parentheses?
That's part of the ion.
Yeah.
So
But it's not gonna affect the multiplication. Shouldn't that be 3 times 4, which is 12?
times 3, which would give me 36, right?
Yeah.
So I look on this side, I get 3 times 3, which is 9, times 4, which is also 36.
Oh, well, yeah, then it's balanced.
Thank you. Okay, are you understanding, Hunter, a little bit of what we're doing?
Yeah. No, I mean, I am. I got to walk through it a bunch of times.
All right, guys. I hate traffic. I can't stand it. When I'm going across the Howard Franklin Bridge and I pull and I'm going my 80 miles an hour over that hump and I have to screech to a stop because there's traffic in front of me, I get really upset. I get really, really upset. I'm mad. I want to see
Going
blood.
so fast, man.
I want to see
Why
blood.
are you going 80 on the Howard Franklin?
I want to see blood. Something has to be up in front of me so that there's some reason that all these people have stopped me from going 80 miles an hour.
Well, now I
Alright,
know
Paul
who
Walker.
tailgated me the other day. Thanks, Professor.
Was it
I'm
a
not
white
saying
car?
he's right.
Was
I'm
it,
saying
was it a white car?
You know, I can't really disclose that information, Professor.
So I am going my 10 miles an hour, stopping every 5 feet. And I'm going up there and I get to where this crash is. And I look and I stare. Now, ladies and gentlemen, did I have anything to do with that original crash?
No.
No.
I may cause another one, but I
Yeah.
had nothing to do with the original crash, right? I
Nope.
am what? What am I doing at that crash?
Observing.
I'm
Being
observing.
nosy.
All right, better yet, I'll give you another example. I'm sitting in row WW in Raymond James Stadium, and I watch that pseudo goat, Tom Brady. I watch that pseudo goat
Whoa.
throw.
Is the real
I watched this guy throw a pass that lands right in the belly of the middle linebacker, who runs it back for a touchdown. And I'm up there screaming my bloody head off. Now, did I have anything to do with throwing the ball?
No.
Did I have anything to do with catching the ball?
No.
What was I doing? What do they call the people in the stands?
observers?
Spectators.
Spectators. All right.
Are we going towards a Schrodinger thing?
No,
Okay.
we are going towards spectator ions. Sometimes there are things which have nothing to do with what is going on. The ions that have nothing to do with the reaction are called spectator ions. And so we are going to learn about spectator ions and ionic and net ionic equations. Remember, you have to look. You have to look at these things. Those are the 4 designations you have for the things that are in your chemical reaction. Those are the state of the chemicals. All chemicals must be designated with one of these 4 states. So, if I am looking at this reaction, I have to break this up because once I put aluminum chloride into water, it gets broken up into its individual ions. So I'm looking at this. Aluminum chloride, when it goes into water, breaks up into its aluminum ions and breaks up into its chloride ions. Victoria, how many aluminum ions are there in 4 AlCl3s? Victoria, is your mic on?
I was muted. Look at me. Yeah.
So if I have the compound 4 AlCl3s and I put this into water, how many Als do I have?
4.
I have 4 of them. How many Cls do I have?
Technically 12, right?
Not technically.
You
That's
do
how
have
many
12.
12.
Yeah, 12.
Okay.
Right.
So to identify ions, I need the number of them. I need the chemical symbol. I need the charge, and I need the state. I need those 4 things every time you designate an ion. So if I'm going to break this up, if these things are aqueous, my AlCl3, I've got 4 Als. They have a +3 charge. I have 4 times 3 Cls. They have a -1 charge. So from this one compound, I have 4 Al3 plus aqueous plus 12 Cl minus aqueous. Okay? We're gonna work at the second one here in a second. Christina. Christina,
Yes.
okay, let's look at this second compound. Is it aqueous?
Yes.
If it's aqueous, it breaks into its ions. So how many leads do I have?
3.
3 leads. What's the charge on it, Christina?
Um,
You're not going to find it there.
4. I mean, yeah, 4.
Charge is 4. The NO3s are a -1. So to balance it, the leads have to be a +4. So I have 3 Pb, 4 plus aqueous. Now, Christina, how many NO3s do I have?
4.
Times, don't forget the
Oh, yeah,
coefficient.
12. Sorry. Yes, 12.
I have 12 NO3 minuses that are in the aqueous state. I've taken up the left side. All right, Chase.
Yeah.
Okay, Chase. Got to go back. All right, Chase.
Yes, sir.
Is the next compound AlNO3 taken 3 times? Is that aqueous?
Which one is it?
AlNO3 taken 3 times. It's the first one on the product side. Is it aqueous?
Yes.
If you see aqueous, that means when it's put in the water, it splits into its ions. Okay? Chase, how many ALs do I have?
4.
4 of them? What happened there?
Screen's foggy.
No, yeah, my thing got foggy. I got 4 ALs. Do you know what the charge is, Chase?
I do not know.
NO3, do you know what the charge on NO3 is?
-1.
How many of them do you have?
3.
Say it.
3.
So you have 3 of them, 3 times a -1. What's the charge on the AL?
3.
So I have 4 AL plus 3s plus how many NO3s, Chase?
So would it be 7 ALs?
Not 7. You multiply them. You don't add them.
Oh, so it'd be 12 ALs.
Not 12 ALs, 12 NO3s.
NO3s.
You already said we have 4. The subscript on the AL is 1, so we only have 4 of those. But the subscript on the NO3 is 3, so we have 3 times 4, 12 of them. Okay?
Okay.
So, let's see. Who wants a challenging question? Who can handle a challenging question? Kevin.
Kevin said his mic is not working. Also, Fabiana's mic isn't working.
I could give it a shot.
Oh, low.
Don't laugh at me though.
Go easy on him, Professor.
Do you see that, Hunter? Do you see the S?
Okay. Yes.
That means it's a solid.
Yep.
Do you think it forms ions in water?
No, because it's not aqueous.
It's a solid. It stays together. So
Yeah.
when you see something that's a solid, you leave it alone.
Okay.
Okay? So how does this reaction really exist? All I'm going to do is just point out what you said. I got 4 Al 3 pluses aqueous plus 12 Cl minus aqueous plus 3 Pb 4 plus aqueous plus 12 NO3 minus aqueous, yielding 4 Al 3 pluses plus 12 NO3 minuses plus 3 PbCl4s. Now, guys, do I have anything that's the same left and right on this equation?
Yeah, you do. The 3 PbCl4 solid. It's on the all the way on the right.
It's on the right, but do I have a PbCl4 in the reaction side? Let me try and show this to you better. That's not gonna work. Nope, this isn't working.
You have it as two separate bullet points, so it's not going to go side by side.
Thank you. Thank you very much. Hunter, do you see that the PbCl4 is totally unique from everything that's on the left side here?
Yep.
All right, what is the same left and right though?
Give me a second. I'm trying to look. It looks like the 4 aluminum 3+ aqueous is.
So they haven't changed, have they?
No.
Let's eliminate them. We don't need them. How about what else is the same? Somebody else figure out something else that's the same.
The 12NO3 and O3.
12 NO3s. Those aren't changing either. But the PBs are changing and the CLs are changing. So what's really happening in this reaction, I've got 3 PB4 pluses that are aqueous reacting with 12 Cl minus that are aqueous to make 3 PbCl4 solids. That's what's really happening in the reaction. So when I'm dealing with the ionic equation, I have to split everything that can be ions into the ions. When I'm dealing with the net ionic equation, I'm eliminating everything that is the same. The only purpose for having the Al in there is to deliver the Cl. The only purpose for the NO3 is to deliver the Pb. They have nothing to do with the actual reaction that's going on. An ionic equation is an equation that expresses a reaction in ionic form. So what we're doing with an ionic equation is we're splitting up everything that's ions. So if I have an AB aqueous with a CD aqueous, this splits up to A plus B minus plus C plus D minus. If that makes a solid compound AD, that stays together. But I have to split up the other aqueous compounds, C plus and B minus. Is this kind of making sense, guys? Marie? Have I lost you, Marie?
No, I'm here.
Okay. All right. If I'm dealing with NiBr2, Marie, and that is aqueous, how many NIs do I make? How many are in the compound?
Okay. B, it's -1.
Okay. How many of them are there?
2.
2 Br minus. Right here. How about INIs? Marie, I'm going to get
+2.
Marie. Yes, plus two. There's one of them. I'm getting feedback.
Yeah, there's a lot of echo. My ears are gonna pop.
You just need a visual. Okay, so what Marie said was we saw that NiBr2 was aqueous, so we split that into Ni plus 2 plus 2 Br minuses. Now, how about the CaCO3? Armethea?
Yes.
Armethea, hi.
Hi.
Is the compound aqueous, Armethea?
Yes.
I'm not. I promise you that I ain't doing that. I really.
How many sodiums, Armethea?
Here. 2.
2? What's the charge on the sodium?
Sodium is +1. I mean.
Yeah, absolutely. So if I'm designating the ion that's coming from sodium carbonate, I've got 2 NAs, it's a +1, and this says it's aqueous. Okay? Armethea, how many CO3s do I have?
3.
No, that 3 is part of the ion.
Oh, okay. 2.
Does it have a parentheses, Armethea?
Mm,
No parentheses, right?
no.
So if it has no parentheses, there's only one of them.
Okay.
So I have 1 CO3. Do you know, Armithia, do you have your polyatomic? Do you know what charge on CO3 is?
CO3 is negative
Negative?
2.
Negative 2. So I'm going to call the CO3 1 CO3 negative 2 aqueous. Again, when I'm naming ions, I need a number, I need the chemical symbol, I need the charge, and I need the state. Okay?
Yeah.
So let's see who else I can bother. Jennifer.
Yes.
Okay. When I do that, I make 2 NABRs.
Mhm.
So Jennifer, how many, it's aqueous, how many sodium ions do I have?
2
2 Na. What's the charge on sodium?
+1.
2 Na plus 1 aqueous. How about the bromines?
2 bromines.
What's the charge?
Charge is -1.
And it's also aqueous. Okay. Terry, what about that
Yes, sir.
last compound? Do I split that last compound up? The NaCO3, do I split it up?
No.
Why not?
I can't explain it.
Anybody out there know why?
Because it's a solid.
It's a solid, Terry. It stays together when it's a solid. Okay.
Okay. That's what I was looking for.
All right. Now, these bottom 2 are my equation for this, ionic equation for this. Is there anything the same on the left and right? From Ni plus 2 to CO3 minus 2. That's the reactant side. 2 Na pluses to NiCO3 solid is the product side. Is there anything the same left and right of the arrow?
The bromine,
Yes.
Bromines are the same and
the sodium.
Sodium.
so if I'm looking for my net ionic equation, it's going to be Ni plus 2 plus CO3 minus 2 aqueous, yielding NiCO3 solid. Are we good? We've already done that one.
Wait, so the ones that are the same don't show up in the products?
Hayden, I'm sorry, ask the question again, please.
The ones that are the same don't show up in the products?
Yes.
Okay.
Okay, Hayden, do you see this slide that I have right there?
Yeah.
All I'm doing is taking the things that are the same and eliminating them. And that leaves me with my net, with my, God, I can't, where did it go? I'll put a new slide in. That'll fix it. So when I eliminate those, Hayden, that's what I'm left with. Nope, that's not right. Ah. How about this? All right, so when I eliminate the sodiums and the bromides, Hayden, this is what I'm left with. This is the net ionic equation, okay? Okay. Are we good, guys? Are we good with that?
Yes.
Okay, Hayden, I got you out here. Hayden, have you ever had a boyfriend you've left for roadkill because there was a hotter guy around?
I have not.
Wow, what an obscure example.
Very specific,
No.
Professor.
Jennifer, have you ever had a guy you've left for roadkill because there was a cuter guy there?
No, not as harsh as that.
Christina.
Listen, maybe I'm just older than y'all, but yes, absolutely.
Yeah, y'all just
Wait. Christina
Somebody
didn't
honest.
just leave. Christina didn't just leave him for roadkill. She took the bus and rode over him a couple times.
You know?
Oh my God.
Okay, now we got to look at the reactants. All right. Remember, I said half of the battle of doing these reactions is looking at the reactants and determining from the reactants what the type of reaction is. So we're going to look at the reactants. If I have a neutral metal plus an ionic compound, I have a single replacement reaction. Or the alternative to that, if I have a halogen with an ionic compound, that is recognition for a single displacement reaction. Now, again, we're going to bring back the swinging Flintstones. Fred's at a party. Fred sees Barney and Betty. And just like Christina, Fred saw Betty and said, "Oh, I like Betty." Kicks Barney off to the side. Fred's now with Betty, and Barney is just crying his eyes out on the road, wondering what happened. Or Fred and Wilma are together, and Betty sees Fred. Betty likes Fred. So Betty throws Wilma to the side of the road, and now we have a Fred-Betty new couple. Chemicals are the same way, guys.
Man, chemicals, heartless.
Yeah. They have no hearts. So either a non-metal is going to replace a non-metal ion, or a metal will replace a metal ion. That's what's going to happen here. If I have an ionic compound with a halogen, if the halogen is more active, it will kick out the anion and make a new compound, AC, and the anion will link together with another one of them and make B2. Or if I have a metal, the metal will kick out the metal ion, making a new ionic compound and neutral metal. Let's see about what's happening. Let's see if I can, I'm going to give you an example here before we do anything else. Something I just did. In our 2045 lab, we did this last week. Aluminum reacts with copper chloride, so that the aluminum will now replace my copper in the copper chloride to make a new compound, aluminum chloride. And what is left over is neutral copper. All right. Now, how does this happen? If I look at these things, how do I know that the aluminum is going to replace the copper? The way I know that is if aluminum is more active than copper, aluminum will end up being ionic. Aluminum is more active than copper. When we start out, aluminum is by itself. It has no charge. But when we put it in, it's more active than copper. So what it wants to do is it wants to give its electrons to copper and become ionic. Let me see if I can draw another analogy. Terry, I'm a dope pusher and you're my flunky.
All right.
All right. Who has more power, me as the chief of the cartel, or you as my flunky?
You, sir.
All right. So I have a kilo of cocaine. I'm trying to
right.
get past customs. I
Okay.
have more power. So who do you think is going to carry the cocaine through customs?
Me, because I'm
gonna
expendable.
push. I'm going to push that cocaine and you're going to have it. Same difference. Aluminum has more power than copper does. So aluminum is going to give its electrons to copper and it is going to become ionic. Copper is going to accept the electrons and copper is going to become neutral.
Oh, so
The
that's
more
how-
active species will always end up being ionic. In other words, it will have a charge. This slide is available to you. Don't take the time to copy this down now. Just realize that there is a rating system of metals. And we know lithium is more active than sodium, which is more active than aluminum, and so on and so forth down here. If I was dealing with the anions, fluorine is more active than chlorine, which is more active than bromine, which is more active than iodine. Remember, the more active chemical will end up ionic. The more active one will always end up in the ionic form. And the other rule, if a reaction occurs, then the reverse reaction will not. What I mean by that is aluminum is more active than copper. So this reaction goes. On the other hand, if I try and put the products on the reactant side, nothing will happen. So if the reaction goes in the forward direction, the reverse reaction, by the reverse reaction, I mean putting the products as the reactants, the reverse reaction will not go. It's two rules we have to deal with. All right, let's look at some practical examples. I've got chlorine and I've got a salt. I've got a halogen and a ionic compound. Recognize it as a single replacement reaction. What happens? The halogens will make ions. I have to look on my chart. Chlorine is more active than iodine. It will end up ionic. So I'm looking at it in this state. Right now, chlorine is neutral. What happens is the chlorine becomes ionic by getting a charge, and then it links up with the cation. So the chlorine reacts with the sodium iodide, replaces the iodide, and I'm left with neutral iodine. On the other hand, if I have a metal, metals become cations. I look at magnesium, I look at copper, I look at their activity series. Magnesium's here, copper's way down here. Magnesium is way more active than copper. So in that scenario, magnesium is going to become ionic. Magnesium will replace the copper, making magnesium chloride, and copper metal left behind. Questions, guys? What is actually happening? I'm getting an ionic reaction. My AB is aqueous. It splits up into A plus B minus. The D, because it's in close proximity to the A plus, can give its electrons to A, neutralizing A, becoming a cation itself. Net ionic equation. The B minuses stay the same. So in actuality, the only thing that's happening here is my cation is getting changed to a neutral element, and my metal is getting changed into an ion. If you add sodium to copper chloride, look on the chart. Sodium, way more active than copper. Jennifer, does a reaction happen?
Yes.
It's more active, a reaction will occur. So when the reaction occurs, the sodium replaces the copper, giving sodium chloride. The copper is neutralized to a metal. Okay, Christina, if I put copper with sodium chloride, will I get a reaction?
No. I'm guessing, without a doubt. That was a guess.
Two things are with your favor. Remember I said if the forward reaction goes, the reverse reaction won't? So if I put the products together, nothing's going to happen. That's the first thing. And the other thing is, if sodium is more active than copper, look at it. Isn't it already in an ionic form? If it's already in an ionic form, nothing's going to happen. It's already ionic.
Right, okay.
Okay. On the other hand, if we have halogens exist as a diatomic molecule. So what you're going to see is the neutral entity is going to have a subscript 2 by it. If I put chlorine next to Ki, chlorine is more active than iodine, so I do get a reaction. It replaces the iodine in the Ki formula to make KCl. The iodine then neutralizes. but it has to exist as I2. All right. By show of hands, who's completely lost on this now? Talk to me. Neela
So
raised the hand.
if you're going backwards in an equation, it's not going to react. You said that, right?
If chlorine reacts with Ki to make KCl and I2 plus KCl will not react.
Why is that? Because the energy is already spent, or
No, it does it for a couple reasons. One, chlorine is more active than iodine, right, Andrew?
yeah.
When I have KCl, isn't chlorine already ionic?
Yeah.
So if it's already ionic, it's not going to do anything to make itself more ionic. It's ionic already.
Okay.
So if it's ionic already, it does nothing. There's nothing more it can do.
The action potential already happened then.
Correct.
All right.
Neela, talk to me. What are you not understanding?
Why?
Why does it happen?
Yes. Why does it make sense?
You won't get the explanation for this until you get to electrochemistry. It has to do with something called reduction potentials. All right. And sodium wants to be an ion more than copper does. Okay. So it has a greater potential to reduce like that. Neela,
Okay.
I know this isn't making sense to you. You won't get the full explanation until you get to Chem 2.
Okay.
Bottom line. Let's see if I have some. Yeah, I have some single replacement reactions. Bottom line. You recognize it. Metal plus an ionic compound. We'll just concentrate on those for right now. Metal plus an ionic compound. What you have to do, once you recognize it as a single replacement, you got to figure out what the cation is. Okay? Cation in AgNO3 is going to be the silver. That means I'm comparing silver to my magnesium. Then I go up. I find my activity series. Okay, Neela, do you see magnesium? Do you see magnesium? Yes. Do you see silver?
Yes.
Which one is more active?
Magnesium.
Magnesium is more active. Keep that in mind.
Okay.
So when I get down here to my reaction, if I can ever find it again. When I get down here to my reaction, do you see, Neela, that the magnesium is neutral?
Yes.
It wants to be ionic when it's faced with silver. Okay? Because it's more active. The way it becomes ionic is it replaces the silver. When it replaces the silver becomes neutral.
Okay, I see.
So when I do this, I end up with that compound plus Ag.
Okay.
And to make this balanced, I would have to put a 2 in front of that and a 2 in front of that. Okay? Neela, is this making a little more sense?
Yes.
Okay. Let's try the second one. And let's see, I'm going to get somebody that's buried, Gate. Gate, are you there?
Yes, sir.
All right. You're going to be looking at iron plus copper chloride. we're going to go up to the, find the thing. I'm just going to copy this in because I'm getting tired of finding it. Okay, Gaith, can you see in there? Iron and copper. Which one is more active?
Which one am I? Oh, I'm looking. Okay, Fe and iron and copper.
Iron and copper. Which one is more active?
I would say iron.
Iron. It's got the greater number of greater signs in front of it, right?
Right.
So iron is more active than copper. Remember, the more active one wants to be ionic. So, does this reaction go, Gabe?
Would be like Fe. Shit. Oh, FeCl. Three, because you're adding. Yeah, sorry. That's 3, and then plus.
No,
the
you wouldn't
2.
know that, guy. You wouldn't know that.
Oh, I wouldn't know that. Oh, okay.
And what's the other product?
Cu. 2C. Well, see, that's kind of confusing.
No, you don't. You wouldn't know that because iron is a type 2 metal, so you don't know whether this is going to form FeCl3 or FeCl2. You don't know that. I have to tell you that.
Got you. Okay.
Again, balancing this, I got to put a 3 there and a 2 there. 2 has to go there. 3 has to go there. Now, the reason it went, iron is more active than copper, so it replaces the copper. Father Jennifer, Leandre, you out there?
Yes.
Okay. We have silver and what's the cation for HCl?
One second.
Leandre?
I'm looking for it right now.
Okay, you're not going to find it there. You're going to see it on the screen. Cations are always listed before anions. So in HCl, what's the cation?
Ag.
Ag is a neutral metal. In the compound HCl, what's the cation?
Hydrogen, right?
Hydrogen, yes. So what we're going to do is we're going to compare the neutral metal with the hydrogen. Okay, Andre? What is more active? Is hydrogen more or less active than silver?
Hydrogen is more active.
Okay. Now, is it already in the ionic form?
Yes.
If it's already ionic, it's already ionic. Is anything going to happen?
Yes, I think so. Would the Ag and Cl combine?
No, that's what you think would happen. But Ag is not powerful enough. It's like the flunky trying to give the cocaine back to the cartel guy.
If Fred and Wilma already did the do, you know what I mean? The ions it's already exchanged, you know what I mean?
Pebbles is already in the Pebbles is already in the making. Leandre, forget what Hunter's saying right now. Block it out of your mind.
All right.
All right. If H is more powerful than Ag, okay? Is the drug cartel guy going to accept the cocaine back from the flunky?
No.
All right. The H already is. He's the strong guy. Remember, the strong guys in this scenario, the strong guys are the ones that push their electrons on the other thing. Silver is too weak to force its electrons on hydrogen. Silver is too weak. Because silver is too weak, nothing happens. Okay, Leandre?
Okay.
All right. They'll give you another one. That was
Oh.
a tricky one. We'll give you another one. Sodium and magnesium. Which one is more active, sodium or magnesium?
Sodium.
So, is it an ion right now?
No.
Does it want to be an ion?
Yes.
So, if it wants to be an ion more than magnesium does, then it's going to replace magnesium.
So it'd be
And
sodium SO4 plus Mg.
absolutely. What's my other product here, Leandre?
Magnesium.
Good job. So we put a 2 there. And we're balanced.
All right.
Okay.
Yep.
Who else do I got to pick on? Mariah. Have I
Yes.
called you yet tonight? Have I picked on you yet tonight, Mariah?
No.
All right. We're dealing with zinc and potassium. Which one is more active, zinc or potassium?
Potassium.
All right. Potassium is more active. Is it already in a ionic form?
Yes.
Is zinc powerful enough to displace it?
No.
So does anything happen?
No.
Say it with more confidence, Mariah. No.
No.
Nothing happens. All right. Questions about single replacement reactions, ladies and gentlemen? Questions?
No. So basically, it just comes down to who's more reactant.
Who's more powerful? Okay, Terry? What you're looking at is you're looking at this activity series. And the one that is more powerful, the one closest to lithium, of all of these, lithium is the most powerful, gold is the least powerful.
Is there any
So-
like shorthand to this, to where I
That's
can
it.
like look at the table, or
That's
is
it
that
right
just
there. That's it.
Okay.
Lithium is greater than sodium, which is greater than potassium. How can I make it more shorthand than that, Terry?
No, I was just saying, like, if I were to look at the periodic table, is there like a trend there, or is that just something you just have to commit to memory?
You're not going to have to commit it to memory, Terry, because I'm going to give you this chart.
Hallelujah.
You will have this chart during the test.
Man, I
Okay.
don't believe in God, but this guy right here, y'all see that?
By any chance, would we also have the one chart that shows if the
Yes.
equation?
You're talking about the solubility chart?
Yep.
Yes, you will have that as well.
Okay, thank you.
When's our next test?
Sometime in the future,
Oh, wow. Okay.
before break. I got it as probably March 4th. I may change it from the 2nd back to the 4th. Judging the way we're getting, the speed with which we're going through these things. I'll be able to tell you that a little better next week. All right. Slight review for the single replacements. Recognition, neutral metal plus an ionic compound, single replacement reaction. The metal will replace the cation. if it is more active. All right. Now, third reaction we have, acid-base reactions. These are going to be a piece of cake, guys. Acids, you recognize an acid by the formula beginning with an H. A base is a formula that ends with an OH. You have to have each of them to have an acid-base reaction. If you have an acid but no base, not good. If you have a base with no acid, not an acid-base reaction. The beauty of this, it acts the same as a double replacement reaction. So if I have HB plus COH, recognize it. First compound has an H in it. It's an acid. Second compound has an OH. It's a base. The products of an acid-base reaction, water and a salt. And this is beautiful, guys, because all you got to do is take the H, link it up with the OH. You have water. The salt is the ionic compound that's left. If I split this up into ions for my ionic equation, I get H plus B minus plus C plus OH. I make water and I make C plus and B minus. Elizabeth, do you see the ionic equation here?
Yes.
Is there something that's the same left and right on that equation?
Would it be the B and the C?
B minus and C plus. So if I eliminate those from this equation, my net ionic equation is going to be H plus OH minus making water. Ladies and gentlemen, if you have an acid-base reaction, you always know what the net ionic reaction is. It's kind of like you have to pee, you make water. Come on, that's the best joke I've told tonight. That's the most original joke I've made tonight.
I was laughing in my head.
The best one's a swinging Flintstone.
Seriously, a net ionic equation of acid-base reactions, H plus OH minus makes water. If I have my equation, HCl plus NaOH, my products are always going to be water and the salt that's left over. I eliminate H and OH to make the water. I'm left with Na and Cl. My products are water plus NaCl. Again, my net ionic equation is going to be H plus OH minus making H2O. If I react sulfuric acid with potassium hydroxide, again, the H2 reacts with OH to make H2O. My potassium reacts with my SO4 to make K2SO4. There's my balanced chemical reaction. Phosphoric acid plus NaOH makes water and the sodium phosphate. Victoria, H2S and AlOH taken 3 times. Name me one product.
You've already picked on me enough tonight, Professor.
This is the last one. Maybe.
Name a product?
Yeah. What did I tell you? What did I tell you was the product each and every time?
Is always water and a salt.
Okay, so yes. I was giving you a lob, Victoria.
I know.
So my first product here is going to be H2O. What's left, Victoria?
You just have the sulfur and the aluminum.
Balancing this sucker out. I think it's gonna be 6, 6 and 6. Okay. Who else? Who haven't I picked on? Somebody want to volunteer for the next one?
Can I try?
Go for it.
Would it be H2O?
It would be. What's left, Elizabeth?
Hold on, my screen's glitching as you're
No,
typing.
your screen's not glitching. I'm glitching.
Well,
There we
no,
go.
my internet's slow, so while you're typing, it's loading in slowly.
Okay. So. No.
Yeah, I shouldn't have taken this one. I'm kind of lost now. It always starts with
yes.
H2O. It always starts with water, but
I was trying to trick you is what I was trying to do, and I didn't realize it at first. Okay, Elizabeth, now. Water is your first product. What's left?
NaNO3.
Cool bananas, guys?
Yeah.
Okay. What do you need more practice on? Because I don't want to start combustion reactions. The last 3 reactions are going to go like that. What do you want practice on, guys? We've gone over net ionic equations, ionic. We've gone over single replacement, acid bases.
We could practice balancing equations.
Okay, Hunter. What are my products?
Sorry, I was muted. So it looks like we got 3 hydrogen, or no, it looks like we have hydrogen,
Again,
3 potassium.
Hunter, let's slow this down. First thing, recognize what kind of reaction it is.
H2O.
What kind of reaction?
What do you mean, like acidic, or what do you mean?
You have 3 choices right now. You have double displacement, single replacement, or acid base.
Double.
All right. What does this start with? What does this compound start with, Hunter?
Hydrogen.
What does the second compound end with?
Let me see that. Is that OH right there?
That's OH. So if one compound starts with H, the other ends with OH.
Then that's an acid, right?
That's an acid plus a
hydrogen.
Nope. What's OH? What kind of compounds are OHs?
Honestly, I can't tell you off the top of my head.
Somebody help him.
That's
acid.
Acid what, Christina?
Acid
base.
base.
Acid base. Hunter, you recognize this because the first compound begins with H, the second one ends in OH.
Yeah.
Acids begin with H, bases end in OH. Now, acid bases, do you remember what one of the products is? Always.
That's I have it in my head. Honestly I just can't say it for some reason.
That's fine. Somebody help him.
Water.
Water. What happens, Hunter, is the H reacts with the OH to make water. Now, Hunter, what's left?
That PO or PO.
Okay,
And B.
that's left. And what else is left?
The BA.
BA. I have to put the BA first because it's the cation.
Yeah, barium.
All right, remember we said never carry over subscripts. Now, the H2O. H2O is balanced. It's going to, H2O is always there's always a balanced chemical.
All right.
What's the charge on the barium? Look at your periodic table.
Barium, I know that's +2.
PO4?
What's the
Phosphate.
yeah, phosphate. Sorry, I'm trying to find it. Should
Somebody
know.
help him.
3-.
3-. Okay, Hunter?
Okay.
All right. Look back to the screen, Hunter. So a barium is a 2+,
Yep.
and phosphorus is a 3-.
Okay.
What are my subscripts going to be?
Honestly, I can't even see this screen. I'm trying to blow it up right now.
Better?
Yeah. The subscripts are what, 2+ and 3-?
No, that's not the subscripts. Barium has a 2+ charge.
Yeah.
Phosphate has a 3- charge.
Then the subscripts what are just 1 for barium?
Hunter, if it's 1, then 2+ is never going to equal 3-.
No. Then you tell me, honestly, I'm lost now.
How many
Oh, phosphate.
bariums, guys, do I need?
2.
2 or 3?
3.
3, because you have
Why
to
does it-
balance it. You have
why
to
would-
balance it.
So
It's all good. We can still see it.
okay. Now, if barium is a 3, what does the PO4 have to be?
2.
2. Hunter,
Because the other side.
yes, basically, the barium's a +2, so I got it 3 times +2 is a +6. PO4 is a -3, 2 times a -3 is a -6. They're balanced. Okay, Hunter, are my bariums equal left and right?
Yeah.
I got 1 times 1 over here. I got 1 times what over on the right side?
Is that 3?
3.
Yeah, so it's not.
Okay. Fix it, Hunter. What do I have to put where? What number do I have to put where?
You'd have to put a like a 1 on the left side or something.
If I put a 1 on the left side, I still have 1 times 1. That's not equal to 1 times 3.
Or you'd have to put a 3 on the left side.
3 there. All right. Okay. Now, I told you when you're balancing them, you don't mess with the hydrogens or oxygens. So I have a PO4 here. How many PO4s do I have over here, Hunter?
On the left or the right?
The right.
You have 2.
How many do I have on the left?
You have 3.
No.
No, you have just 1 then?
Just one. So what number goes in front of H3PO4?
It's going to be 4.
If I do that, then I've got 4 times 1. Is
Yeah, but
that
didn't we
equal
say
to
there's
1
4 on the
times
other-
2?
What do we say we have on the other side?
We have 1 times 2. We have 2 PO4s on the right. We
Okay,
have 1
then
times.
then we need 2 if there's only 1.
There we go. Okay. Now, I've got, this is going to be a little more involved. Not what I wanted to do. I've got how many hydrogens in the phosphate?
So you got 3 hydrogens.
Times
Oh, 6 then. So 6 hydrogens.
from that one. Now, I've got how many hydrogens from this subscript?
2 times 3. So 6.
And there we go. So if I've got 6 hydrogens and 6 hydrogens on the left, what number goes in front of the H2O?
It's going to be 6.
12.
Not 12,
6.
6, because you're multiplying.
Yeah.
Whoever said 12 is wrong. You're multiplying the subscript 2 by a 6 to make 12.
Yep.
All right, now Hunter, how many oxygens do we have?
2.
Times?
3. So 6.
How many oxygens do we have over here?
We have 2 times.
No, not 2.
Or, 1 times 2, then just 2.
No, 1 times.
1 times 6. I know you hate me so much right now.
We love you just the same, Hunter.
Okay, that may Hunter, this may make it easier for you. What's the subscript on the oxygen?
1
Times
times 6. 6.
6 oxygens. Over here, I have how many oxygens from this subscript?
Yeah, so there's 2, and then times it by 3, it's 6 as well.
So the oxygens are balanced.
Yep.
I've got 2 plus times 3, 6 plus 3 times 2, 6 over here, 6 and 6, 12 hydrogens, 6 times 2, 12 hydrogens.
Yep.
I've got 3 times 2 oxygens for 6 oxygens, 6 times 1, 6 oxygens. Oxygens are balanced.
Yep.
2 times 1 PO4 makes 2 PO4s. 1 times 2 PO4s makes 2 PO4s. They're balanced.
Yep.
3 times 1 barium balanced, or 3 times 1 is 3. 1 times 3 is 3.
Yep.
Both of those are balanced.
So it's completely balanced.
That's completely balanced right now. Okay?
That's crazy.
Hunter, did you remember that worksheet I showed you?
Which one?
It's in the homework, the extra homework I give you. Believe me, do that. Go through those, practice them.
Okay.
Christina, you went
Yeah.
like this. I thought you had
Yeah,
a question.
no, I do. Because I don't understand how on the left, there's like a total of 6 hydrogen. Or I mean
Okay.
12, because there's 6 in the first and 6 in the next one. Like, I don't understand how. Ah, got it. Check.
Oh, I didn't know
Right?
what I,
2.
okay. Sometimes when I don't use the actual subscripts, it makes it a little harder. Okay, in the first compound, the subscript on the hydrogen in the first compound is 3. The coefficient is 2. 2 times 3 makes 6 hydrogens, okay?
Right.
But I also have hydrogens contributed from the second compound. I've got 2 times the 1 subscript inside the parentheses for 2 times 3. I've got another 6 hydrogens from the second compound. I add those 2 together. That gives me 12 hydrogens on the
Got it.
left.
It makes sense now. I see it. And yeah, the subscripts help for sure. Thank you.
Sorry.
That's okay. No,
It's
no
just
worries.
when I'm
It's a pain
trying
in
to
the butt.
type these fast, you see the time it takes me to put the subscripts.
Oh,
in.
yeah, I get it. I get it for sure. Thank you. I appreciate it.
No problem. Anybody else have any other questions? I'm hearing crickets, guys. Elizabeth. Are you still here, Elizabeth? Guys?
Can we
this
get
is
more
all
examples, maybe?
No,
What's
I'm
that?
gonna go eat.
Bye. Eat.
Bye.
Thank you.
Actually, your
Thank you,
dog's
Professor.
looking hungry.
Have a good weekend, Professor.
Be wary, your
Bye,
dog's looking
thank you.
hungry.
Bye, Professor.
Bye,
Bye.
Professor.
Bye.
Good.
Erin, I didn't even see you tonight. She's gone. Is Elizabeth still here? Elizabeth? Okay, guys, that's all I have. I will see some of you in a half an hour.
See you then.
Take
Bye.
care.
Oh, leave this thing.
Armethea. Bye.
I'm trying to leave it.
Don't worry, I'll end that for you. I'll end your misery seconds, okay?
Thank you.
Bye.